Hey guys, so refraction isn't a new concept to a lot of you. You would have seen it in some form or another, whether it had been at in separate sciences or whether it had been in your combined science papers. The thing that probably gets overlooked a little bit and doesn't get discussed is that little ray of light that you see from reflection. So when you shine it through a glass block, you see the refraction. That's quite straightforward to see, but there's that little ray of light that's bouncing backwards as well. That's the bit we now want to concentrate on. Now, if we draw this as a ray diagram to begin with, what we have is we've got our glass block, and it's going to adjust the screen here a little bit. You've got your normal line, and what we're looking for is where the incident ray comes in at such an angle that the refracted ray or the reflection is exactly at 90 degrees. Now we can use Snell's law to make our calculation here, because we've still got our angle I, or as we decided to call it, theta 1. And then we've got our R angle here, which we decided to call theta 2. So when we look at the calculation, how it now looks is like this. You've got the sine of theta, which we're going to call C. This stands for the critical angle where you achieve this. Where this is achieved, we call that the critical angle. And what we're going to do here now is we're going to substitute in our numerical values. So we know we're dealing with sine of 90 degrees. We know the angle already. And we know that it's going to be n2 over n1. Remember, you can only use n1 as 1 if n1 is air. That's the only time you're allowed to do that. You will in A level be given questions where both materials have a refractive index different from 1. Now, if we carry out the inverse sine of 90 degrees, we get an answer of 1. So what we can now do is actually we can rearrange our equation, and what it gives us is theta c equals sine to the minus 1, just adjust the screen there, n2 over n1. And this will allow you to calculate the angle of a material that the incident ray should be arriving at to allow you to achieve total internal reflection. And this bounce, or this 90-degree movement, is really crucial when we look at things like bike reflectors. Have a look. Any questions, do email me.